So for new folks, this is our weekly slide template where we go through different topics every week. So welcome to the DevHeads now renamed IoT integration server office hours for the 12th. This is our format. Welcome and introductions. We go through a topical discussion. If there are any community questions that need to be addressed, we hit those up. We talk about what we can do to get 1% better by next week. We go through any asks and gets from the community. So if you have something that you'd like from the community or that you want to offer to other members of the community, that's where you do it. We're compiling a list of design tips and resources. A really good one we just got this week was from Peter. He dropped in a scope that he likes. So I dropped that in there, and then any next steps we have. So since we got some new faces, I'd really like to take the God mode off and give some of you guys an opportunity to introduce yourselves. Abhishek, why don't we start with you because I didn't have to mute you. You muted yourself, maybe.
Yes, sure. Thanks. So yeah, I'm Abhishek Avasthi. I'm working at a startup at Bangalore, and for embedded and embedded Linux domain, I have worked on IoT, various kinds of IoT modules, IoT products. We have designed IoT architecture as well. Shisha is my colleague, by the way. He is also here. He's typing on the chat, and yeah, so that is me. I work on embedded Linux and embedded domain as in complete. I'm comfortable right now with Linux, as in I can build and I think in that manner where I can be able to build anything from STM32 to anything into Linux. So I saw Electro's this post where he had made this Jarvis kind of a thing from Alexa. A great post, man. I must say I didn't got the time to reply to that, but apparently one of the backend chips does have. So basically there is a library named as Wanson, WANSON. That library is usually used for this thing, voice recognition for basically a wake word recognition. So you can put that chip, that integration itself to make like direct Alexa. So yeah, that was my insight for that post. A great post, man. You're working with 3D printers. I want 3D printers. I'm looking forward with that area.
Yeah, for sure.
Would be a great collaboration with you, man. Yeah. So yeah, that's me. I am an autodidact tinkerer. I like to call myself an autodidact tinkerer. I learn by myself. I tinker around stuff, and this is LuxFox Pico Mini, Pico Pro. This board apparently is covered by Pallav. I like he has made a post and he has covered this board, by the way. You can check his post also.
Cool.
So yeah.
Well, thanks a lot, Abhishek. Really appreciate that. We'll go next. Electroboffin, do you want to introduce yourself?
Yeah, for sure. Hey, hi everyone. So my real name is Padmala Rawal, and I'm basically from Haryana. And so I am a lot more interested in 3D printing, robotics, which is more innovative rather than just tinkering with the stuff and learning stuff. I prefer to apply everything to whatsoever I learn, and then I can learn anything. So I am into 3D printing, PCB designing, CAD designing, robotics, and recently I have shared a project called fastest BO motor wheel, and currently I'm improving that to make the world's fastest 3D printed car. So let's see how it goes.
That's awesome. And you're doing a lot of commercial products at this point, right? Electroboffin, you're selling stuff.
It was all started back around 1.5 years. So I just completed my graduation last year only, and then I was looking for a job, to be honest, but none of the job allows me to do everything because I wanted to work in various domains. So every company wants me to work in a specific domain, let's say write a software or just do PCB designing, but that kind of stuff bores me a lot. So I prefer to start my own and sell whatsoever I want and do whatsoever I want to.
That's cool. Awesome. Srisha, are you able to speak, or are you still tied up?
Hello?
Hey. Hey, can you introduce yourself? You have time?
Yeah, I am. Am I audible? I don't
You
think so.
are.
I'm visible, but okay.
You're audible though.
Sorry, guys. I was commuting, so I joined in a hurry.
Don't worry.
So I am Srisha Nakshatri. I'm a colleague of Abhishek, and we basically work in IoT domain, the company which we are working now. So I am a hardware engineer. So I design backend hardware, basically Wi-Fi chips and IoT hardware. So my experience is with Altium, KeyCAD. So before doing this IoT thing, we were making a submersible pump, basically a BLDC submersible pump. So it was a BLDC submersible pump, so 1 kilowatt. So in the rural India, it's like a government initiated project where they want a BLDC pump. It's a submersible pump inside a borewell. So it runs on the solar. That's the interesting part. So we have to implement MPPT protocol, MPPT techniques on the basically controller itself, driver basically. So accordingly, like input power and output power, we have to measure and then calculate MPPT. And then that was an interesting project. So I worked on it before. I designed the hardware, basically a driver, and then I wrote the software as well. So it's now field testing. It's in a field testing stage.
Nice. Good for you, man. All right. I think the rest of us have been here. So for Peter, Mesh, Christoph, Navdeep, let's do like lightning round introductions. Like, hey, this is who I am. This is what I do, and then move on. So Navdeep, you want to start?
Oh, yeah. Hey, I am electrical engineering enthusiast, like been in this domain for
Said lightning round, dude.
5-6 years around. Oh, sorry, what's happening?
Never mind, just go.
Oh, anyways, yeah, I mean, just been energy domain for around 5 years now, and then mostly into embedded systems, hardware design by profession, and I do a bunch of hobby projects and stuff like that, involved with communities. So, yep. If you're anywhere around embedded systems, let's catch up. And thanks for new people joining this server. Stay tuned.
Yep. Peter, you want to go?
Yeah, sure. Thank you. Hello, everyone. I'm freelancing hardware design engineer sitting in the Czech Republic in the Europe. That's it.
Thanks, Umesh. Umesh, you're muted.
Sorry, I think now it's audible.
Yep,
Yeah.
we can hear you.
Okay, so past 10 years. So basically, I backed from Germany 2014, and from 2014, I'm in India starting companies. So my focus is primarily on IoT. So I also do full stack, like from hardware to the front end software, but I can't do everything by myself. Okay, I'll be very honest. I take a help. I have a big team. I work with them, but I oversee and I understand. But as like every tech entrepreneur, they have to do everything by themselves, right? Even if it's small. So I think I would say like I understand everything, and but I can't do because now my volume of deployment are so high. I can't able to handle everything. So that's like a lot of experience from field. And apart from that, I also run this YouTube channel, kind of pet project in the beginning, and now it's a little bit grown little popularity. So that's basically what all about me.
Yeah, and just for everybody, just so you're aware, what Umesh just described is essentially the point of the server, right? There's so many different elements of a design right now that you have to be able to master that it's just becoming kind of impossible. But with all of us together, I think we've got a nice spread. Christoph, do you want to go next?
Yeah. I first wanted to ask Umesh, can you send the link of your YouTube channel? I'd like to check it out.
Yeah, sure.
Thanks. So about me, I'm Christophe. I am a co-founder of the startup Embeetle. So we develop a new IDE for microcontrollers, which is not based on Eclipse or Visual Studio Code or anything existing. We really started from scratch to make a brand new IDE that's only focusing on microcontrollers, not on general programming. So I invite you guys to check it out if you have time. It would be great. And all feedback is welcome, and questions as well.
Cool. Joseph, your turn.
Okay, good day, everyone. I'm Joseph, a hardware engineer. I do design IoT devices majorly, ranging from consumer products to maybe some industrial designs. So that is basically it.
Cool. Thank you. My name is Brandon, and I really am in Vegas right now. You can see that. That's Vegas.
Wow.
And I'm here for CES. There have been some questions about what I have seen so far this year. And it's difficult for me to comment because when I come to CES and shows, I don't actually walk the floor the same way that normal people do, right? I'm going in just meetings after meetings after meetings after meetings. So I'm going with some very specific intent. A lot of my meetings this time have been around actually connectivity, cellular connectivity, LoRa connectivity. I met with Digi, I met with Tablet yesterday. Incredibly exciting. You know, it's just a bunch of modules on a wall, but what we can do with them actually potentially is. So DB is interested in getting involved from the XB perspective. Tablet obviously has some new products coming out. Some cool companies, Blues Wireless, or now I think they just call themselves Blues, and Once, who does this sort of like universal, they're an MVNO who does this universal one-time cost for cellular company. So anyway, those are some things I saw yesterday. I'm going to try and go back down into one of the halls today. So Peter, that neuromorphic chip you were talking about, they're in a room, they're in a suite at a hotel. So it's invite only. So I submitted a request to see if I could get in there, but I haven't heard back yet. Today's the last day of the show. So I'll do my best. Other than that, if there are like general trends that I could mention, a lot of Gen AI stuff, honestly, at CES, there's a lot of crap. There's like a lot of garbage.
Really?
You know, oh yeah, it's mostly garbage.
Really,
Yeah,
because to me it feels like this is the show of electronics, and I would be surprised that garbage can even find its way inside such a high-standing. But
so I think it's in the context of the show, it's not that important. But CES is like 250,000 people come. It's not. It's like the entire Vegas, right? So there's stuff happening at multiple hotels. The convention center here is one of the biggest ones in the world. And, you know, half of it, not half, but like probably 20% of the shows, like cell phone cases. And, you know, it's just like what we would consider like junk. Right. So, and it's the Consumer Electronics Show, remember? So they're really, this started out as a way that they were selling like next year's TVs and stuff. So for example, they're like AI powered pillows. That was something I saw. You know, like it just like random, like total stuff anyway. But yeah, so right now, every year you're going to see whatever the like buzziest word is. It's going to be attached to everything. So just lots of AI, Gen AI stuff. Yeah. So yeah, I don't know if did you guys see the drone soccer video that I posted?
No.
Yeah.
No,
Good.
Yeah.
In the chat, I'll see if I can pop it up. But
what is a drone soccer?
Basically, they put these like cages
Yeah.
around drones and try to fly them through these suspended rings, and then you tally up the points. Yeah. Anyway, so that's sort of what I've seen in a flash. I'll see if I can share some other stuff. I got some pics and stuff yesterday with you, but mostly meetings around connectivity. So I'm actually really excited about some of the people who I talked to. Numesh, I did speak to the sensor tech guys, and one of the things that I know this guy there really well, Marcellino. One of the things that he suggested, which Christoph, we should talk about too, is they have a new line of Arduino Pros, or a newish line of Arduino Pro boards that have a lot of Bosch Sensor Tech sensors on them that are relatively inexpensive. So that's something to look at too. But I'll see if I can get some of these guys in the server. Anyway, back to the normal meeting. We usually don't do that. So Umesh posed this question inside the chat, and every time, guys, what we try to do is try to have a topic like this where we go over it and see if we can discuss collectively and then get to some sort of resolution. Umesh, you were talking about RF antenna design challenges. Do you want to share your past experience with your Zigbee board and then discuss what you're trying to do now?
Yeah. I hope I'm audible, right?
You are.
Yeah.
Okay, so the moment I posted this question is the time when I was thinking about what if I could able to make the antenna. Okay, and I mean, there's very few people might have think about it, because you get the modules for ESP32, and then people then ask this question, okay, does this make a sense? Why to do it? But the curiosity was that to understand whether I could able to measure the dielectric constant, because what I know from my previous experience was that not only the antenna, I mean the routing, but also the material plays a very important role. And even at one point in time, Sresha has mentioned, the calculations and other things like RF tuning and other things. So even for that, you have to know a very good material. I mean, you should know every property of material, and also the whole curiosity is basically about understanding, whether I could able to do that. And then I search online, and of course there is a financial angle to it. As you know about me, I have a companies, and I always looking for how can I cut the cost over components. So if I do not get the module, I would probably get the component memory and the core ESP32 and put onto the PCB. Now of course it looks crazy because I did it before and I'm using module right now, okay, in the product, along with STM32. So for Wi-Fi I'm using ESP32 in the product, but the real computing is done by STM32 in my product.
Okay.
So the goal was, if we design this, then we have to put the external antenna. And of course, every engineer knows it looks extremely ugly, this external antennas. Then people would say, okay, why not use this ceramic antenna, right? You can have this little ceramic antenna. But then I still was thinking, okay,
What kind of antenna? You said
ceramic antenna.
ceramic.
It's
Yeah.
like
Okay.
small.
Yeah.
But then still back in my mind, because you all PCB design people knows Phil's lab, right? So this guy has posted a video where he did entire routing for um, ESP32 board, and then I looked at that and he said like it may work, may not work, or he's not. I mean, even at that level of expertise, he was saying he doesn't take anything for guarantee. He said like this is just an experiment. He also wanted to try. Now, the question come with why this curiosity comes into mind. That goes back to 2019, because when I started my first business, we were doing home automation, and many of you know when you're young, the first thing you want to make is home automation, right? I don't do anymore, but yes, of course, I did spend a lot of time. I learned a lot out of that, and we were using Zigbee a lot. And when it comes to Zigbee, everybody knows DG's XB S to C is the most popular one. And if you look at the price, in those days, it wasn't that expensive. In those days, you can get it after $12 or something. Right now it's a $29. Today only I checked it. So even those days, I wanted to cut the cost from the DGXB S2C to something that I could take, the chip CC and then design my own. And we as a company with my hardware team, I invested almost around 8 months, and we built the Zigbee. Even going forward, whoever worked with Zigbee knows that DG not only make the Zigbees, but they also have a great suite of software, especially the utility applications. And I also built utilities. But the problem is investing this much time, energy, and effort. I figured out, okay, the PCB antenna that we used for those Zigbee for CC, that we managed to do it, and it was very bare routing. Basically, we got some footprint and then we worked around it. It was like, but it worked. The point is, it worked, but the range wasn't satisfactory. So whole project doesn't make sense if you don't get a range in RF, right? Here it's a completely different in ESP32, because it's not, we are talking about RF, it's a microwave again, right? It's a 2.4 gigahertz for ESP32. So people might think, when I posted that, people were, oh, this guy is crazy, what he's talking about. One hand there is a RF and there's on microwave, but there's a complex story to behind this, right? Why I got all those things. And this time I thought, okay, if Phil's lab does that, why not I should try to get at least understand whole ecosystem, like how it all works and how it can be achieved basically, and then test whether you do not get the range that you want. Let's say somebody can promise 10 meters, let's say 30 meters, you get 10 meters. That's what it happens, when your calculation goes wrong, like width and other things. Even if you have, then you have to go with very complex way. You can use a MATLAB and do simulations, antenna simulations, proprietary software. I know this is all very crazy, but I hope you get the point, like why and where this question came from. And it makes a sense, like someday, somewhere, at some point in time, you have to do it. Maybe even for me, it's not the right time to do it, because if you look at the cost for, the chip and the module ESP32, I think it's just a $1 difference, right? But when you have a volume production and you talk about $1, and if your product is consumer electronics, let's say for one of a client I never talked, we make a vending machines. Now, vending market is so tight. And then you are competing with, like Hindustan Unilever, and then even some Indian and some foreign enterprises who not only sell coffees but sell coffees with the machines, right? So the only way you would succeed in Indian business is Indian market is you cut the cost. Okay. And I'm not saying like I'm going to do it right now, but it makes a sense for me in a long term to achieve that. That's what I'm saying. So that's
Well,
where this, and then I'm interested to know who else have tried that and what they have managed to achieve out of antenna.
Well, the first person I want to ask about the measuring of the dielectric coefficient is Peter. Where do you start trying to gather some of that information when you have to do that, Peter?
Well, I recommend to contact manufacturer.
Peter is right on point, sharp
Yeah.
and well, usually, yeah, that's the case. I mean, before pushing it to the fabric, any design, we have like a fabricator. We go to the fabricator and ask what are the stack ups you have and what materials do you support if you want to change it from FR4 to any other for high frequency RF, you do that, and then by shaking hands, you go ahead with fabrication.
I think FR4 does work because I did a, means my hardware guy have done pretty massive
Yeah, yeah.
research on
It
that. I'm not,
it works up to
so
1
we
gigahertz.
even,
Sorry.
sorry,
Hmm.
go ahead.
Yeah, yeah. No, I was just telling it works up till 10 gigahertz or so, and then the losses which come because of the material, right, will go insanely high. So then you have to go with certain uh, yet denser material, and yeah, that's all.
So I asked Espressive because Espressive is in my city, Pune only, right? So
Okay.
so India office, and I asked whether I would get the Gerber files. And the whole curiosity is not to build this, right? It's not succeed because I know how would you make that without proprietary, the software. This is not easy, simple thing. Even Espressive, uh, for Gerber files, they need to sign NDAs. And then again, you have to have a quantity and promise and other things come into. But I'm interested in knowing like who else have tried and what they have achieved. I hope someone somewhere have tried to design these things, right, around
Yeah.
RF antennas or
Umesh, please let me ask you. If it's the FR4 material, the rigid PCB, there is usually the dielectric constant in the range of 3.8 to 4.2 in majority of cases. And every time I tried to use calculators for impedance, for traces, and everything you need to design, and I tried both ends of the range, 3.8 and 4.2. The difference in the track width or the electric height of the PCB was in the tolerance of a manufacturing profile of the PCB manufacturer. So in my opinion, there is no such a difference if you use number of 4.
Okay, but it seems like you did it, right? You made it, some prototypes.
Yes.
Yeah. And what range you managed to achieve? Because what my experience says, it does work. Now the question is, in the RF, you have a different ranges for different protocols, right? What protocol we go after in RF, let's say. So
The last board I designed was for GPS. The customer was very sensitive for the precise tuning of the antenna, and we used the tau glass, the patch antenna. So I designed precisely only the traces, the PCB, and they measured the manufactured PCB assembly with their VNA, so vector network analyzer, and they measured that there is a difference of the resonant frequency of 6 megahertz at 1.6 gigahertz. So yeah, there is a difference. You can't design the PCB first time right exactly for the resonant frequency without any shift, any offset. So it's normal. It's pretty normal. There are matching networks for matching. There is a matching network between the transmitter and the transmission line, and for the antenna feed between the transmission line and antenna feed, usually two PI cells. So you need to use the VNA or something like this, and to tweak the transmission line for the 50 ohm impedance and the correct resonant frequency. This is normal process. You can't do it from your computer, from the CAD. You need to measure it and to verify the process. So this is why I say use number of 4, because the complete design process should be or must be done. So you need to verify it on the VNA.
yeah.
Cool. Does anybody else have any
that or not?
Sorry?
Peter asked if it helped.
Hello?
Yeah, I just typed if did it help or not, because this is only what
Yeah,
I
I think my curiosity was to ask people in a community who else have tried that, because everybody knows without having proprietary software you cannot able to do all those things, right? I mean, it's not about who achieve the accuracy, who achieve that range. It's not possible. No magic happens, like you can get coffee with 50 cent. So it's not going to happen. But yeah, I think but we all keep our experiments going, right? Like what I said, Phil's lab, he did it. He is very clear and upfront. I'm not expecting this to be like that, but let me just do it and see it, what happens, right? And everybody knows, like when I looked at the Ferenek video where he invited somebody from MATLAB, and she was just using MATLAB apps, and she have a entire library for the antenna simulations. It's too big. It's just doesn't make sense to do all those things, right? But the curiosity is like, who else have tried to do that, and what kind of results they got. And this antenna doesn't live your life that easily in IoT business, because it's not just I shared the Zigbee project, but even for one instance, we wanted to create a beacons out of an RF chip. Now, if you want to customize the beacon, now again the antenna haunt you, right? And then you cannot get this cheaper. You can compete with Chinese beacons, which basically you get cheaper than Indian tea. So again, like you go one project after other project, but you see that requirement is there, and you keep experimenting. Like we doesn't always get the results, but we keep our experiments going just to understand what we get. Of course, in the end, you try to get external antennas, or maybe if you get ready-made, that's absolutely great. If not, but yeah, knowing like what you shared your experience to design and use the coefficient, I think that's pretty curious to know, like who else is trying in the hardware. Because most of, I mean, when I started, it's simple thing. You take the modules, you buy module, put on the hardware, design base boards, and leave it everything, right? But sooner or later, you realize in your designs, you're using 10, 15 modules, and now you have to remove the module one by one, because that's the only way you can cut the cost. I think that's just the reason why keep thinking and exploring. Yeah.
Shrisha, do you have any experience in this? I know you chimed in a little bit in the conversation on the chat.
Yeah. So guys, we at our company also design Wi-Fi modules. Basically, what you are trying to explain, the same thing we are also trying to achieve with a low cost. So we have faced many problems, but not exactly to the antenna design. So what we have is a direct partnership with the Becky. So they are fully supported to us in our company. So we have designed basically the module and the antenna, which I have extracted basically from their previous reference design. So that's how I designed the antenna. And the thing is, we have put the same parts as what they have mentioned in the reference design. And what we had done is additionally, we have sent the modules which we have produced directly to the backend company. So they have tested our module and given us a reply, like what values needs to be changed, what needs to be tuned, and everything. They were like fully supportive for us. Like, so we even got validated. Our design was got validated by the backend company. So this is the advantage if you have like a number in your hand, like you want to produce a lot and you can promise like your product is going to sell a lot. If you have these kind of ideas or like then you can directly contact the seller. Like I think Peter is correct. So you better contact the seller itself or the chip manufacturer, because they will be very supportive on this. They will provide you the reference design. And there is also another layer, like you need a calibration tools which are proprietary. So like even after you get the design, like the module, then even after tuning of the antenna, there are like some fuses inside the controller itself. So those will hold the calibration values of the Wi-Fi antenna. So I think Abhishek has some experience with calibrating the modules. I think he can also join in. I think so. This was all proprietary software. So retuning, I think it's called retuning or something. So it will basically measure the Wi-Fi signals, like ping pong kind of a setup, I think it was. So it was doing. So we also had designed some kind of Faraday cage to do these experiments within. So yeah, these kind of experiments we had done in our company. So this is what my this one. And also is like there are so many issues that comes up when you are trying to make your own module. So I would suggest, like, if it's a very little cost difference, I would say go with a module, because there is so many issues that can come up if you are trying to design your module own modules. Basically you will have a lot of rejections. One is if you are even trying to manufacture your own module in house, and if you're trying to get it manufactured from like EMS services, then it's fine, like they will do X-ray and everything, so you are like sure. Still, like I would say if the cost difference is very small, then I would say go with a module. Yeah.
Awesome. Abhishek, do you want to jump in on the retuning? There you go.
Yeah, so basically, again, talk to the vendor. Vendor will give you the tools. Vendor will give you the support. For the calibration also, the vendor provided us the tools and a Chinese documentation. You convert it to your language and understand it, whatsoever you can, and then make the best out of it. Even they sometimes give the source code, so you can change the parameters according to to your need. And then again, vendors are the key players in this one. NDA is what we need to sign.
Yeah, that's what you don't have to do when you reduce a cost, right? You're saying like
Yeah,
design module. That's what I don't want to do, right? And for the components, yes, absolutely right. We do have some partners in Finland, and we do get the antenna, we do get the values for tuning, but we don't do it in-house, okay? So we do have a partners, those who are um, antenna experts, but then you have to pay them for every piece you produce. So then your goal of engineering to reduce the cost is over there. So you're basically again going back again. Of course, you cannot make, you can't use modules. So you have a freedom how compact you will design your product, right? So let's say if I make the vending product, my requirement is, let's say, sometimes some milk is uh, coming out of it, out of, let's say, compressor, or sometimes there will be some sticky sugar water kind of thing, right? So it's about material properties. So you have a freedom to customize when you don't use module. But then again, for every quantity you produce, for every quantity you're paying, right? So yeah. So basically, tuning means, you said, like circuit tuning, like impedance, uh, whole thing what Peter has explained, right? How you tune the circuits by putting, electronics components, right?
yeah, it's more of a like a ping pong situation again, as Isha explained. So we transmit, we receive, we check the delta, and then we calibrate it again. We reduce the delta again and again and again and again until it is in the range of accept. Basically, there is an acceptable range, and then once the threshold is reached, we leave it to that calibration, and we save the calibration to the flash. So that is like the procedure we can have with ESP modules as well. And I mean, at the end of the day, all the codes are coming from China. So my belief from China is like they usually do this kind of cloning kind of a setup. So you will see similar kind of environment for major products. But
Yeah.
again, if that helps, great.
Yeah, I think the video that Peter has shared right now in the chat box, that's a video that talks about how you do impedance matching. That's where I said, like, MATLAB. This lady used the MATLAB and then shown entire process. I mean, every little, you can simulate every little parameter you can simulate and then come up with the number. But then it doesn't worth the time, right? Like just for $1, and as likely then everybody end up doing NDAs, and yeah, but then everybody end up paying, so you don't have any advantage. So it's like so it's like US made chip has the same cost as the European and the Chinese, right? So it's the same thing. There's no advantage. Yeah.
Even
Let me
sometimes find cheaper.
Mhm.
let me say something. In the video I shared, it's not about the MATLAB calculations. You can use
Okay.
any calculator. It's about the video describes the entire process. They design something, they measure it, they get back to the design, they change something, they measure it again. So this is the entire process is a loop. One thing about the modules. Do you think why are the modules look like they do, and why there is a metal cover and everything? Maybe not everyone knows that those modules are certified, FCC, EMC, CE, everything. This is why the modules are more expensive, because when you use that's such a module in your design, you are clear, because the manufacturer will provide you with the certified certification documents, and you can easily put your design on market. Once you use your own solution, chip, RF antenna, everything, you need to calibrate, you need to certify your design. Of course, if you are living in China or somewhere, you don't need to. Yeah, you still have to, but it's in a modern world, you have to certify your RF
Yeah,
design.
I absolutely agree. And this is very important point. Even just an afternoon, I'm coming from this design, I mean, our testing laboratory. In India, it's called NABL. Okay, it's a national accreditation board testing and calibration laboratories. So today only I'm coming from it in afternoon. This is very important point, but this is of course a long process, right? It's not like you are saying that the modules are not important. Yes, they are important, but as I said, it's just a curiosity. You keep doing it and see, where, let's say some experiment you tried 5 8 years back, then you understand, because in 8 years you have now a lot of new softwares, lot of new way developed how the things been happening, right? So that's the cue. That was the point. And by the way, this video, maybe I have watched I was referring to other video of Fahrenheit. I saw that's from Fahrenheit, so I thought maybe that's the same video. Yeah.
Yeah, at the end, everything. Just one sentence. Everything is about money. Once, as I said, for the entire process, you desperately need the VNA or some similar instrument, and the VNA with 3 GHz range is like $4,000 piece. So you can save for modules, but if you need your own lab and or own design process, you need instruments. It takes money. So it's a balance. Yeah, you need to invest or you need to save.
Yeah. But then, sometimes you're instructor, right? And consultant, and you sell your consulting, but you learn out of it, correct? Not every time you have to do it. Sometimes you just have to learn it. Maybe tomorrow you sit with the bigger stakeholder and you don't have a capacity, but they do have a capacity, right? So the constant, I mean, that was just my approach. You kind of keep tracking what's going on, even if it's not in your capacity. You just understand like what's happening, what kind of, like, 8 years back when I used MATLAB, the highest use of it was software and hardware in the loop test system. And right now I see the application of MATLAB for electronics and designs. I freaked out. I mean, I can't even imagine in those days MATLAB become this much integrated in design. But yeah, you're right, Peter. I understand.
Navdeep, are you using MATLAB in any of your RF design applications? I know it's not necessarily the exact same, but thought you might be able to comment here too.
Oh, yeah, MATLAB not specifically in RF. I have extensively used MATLAB for other kind of modeling and designing filters for like a black box model. So one thing I was telling was the battery management system, state estimation problem for that. So there, it was mostly on getting a lot of battery data and then doing like a curve fitting on that and fitting the model, getting it to the point where you can model a physical system quite accurately and then run it in parallel with the physical system. It's more like a yeah, it's more like what you were telling, like hardware in loop testing also, where you have a mimicked copy of a actual system running and then you basically run tests, and while you want to estimate certain things, you actually cannot probe directly into battery always. So you take input parameters from there and do the calculation. So those things. And RF, I haven't used MATLAB for that application. Mostly these ANSYS tools are what I am using currently, just getting into that domain though. I can resonate what you guys are speaking about the problems faced in product development phase, although I haven't exactly worked on any of these. Uh, with ANSYS tools, what I mostly do is like the simulations, the signal integrity, and even the power integrity simulation for the RF boards. So they're not specifically on the antennas, but more on the power delivery network, which feed to the millimeter wave chips, which are there for the antennas.
Cool. Joseph wanted to say something, but his network is acting up. So really quickly, while we wait for Joseph, Christoph, wanted to give you a chance to talk about any progress that you've made on the tiny Scarab, and maybe some of the stuff we've been talking about today is good food for thought for you as you proceed.
Well, to be honest about antenna design, I don't know much. So, but it was very...
I was actually saying some of this stuff is good consideration for you, maybe, as you proceed designing the tiny Scarab, and I just wanted to give you an opportunity to give any updates that you may have made.
Yeah. So, well, about the tiny Scarab design, it's almost finished. But yeah, the tiny Scarab will be this 10-cent microcontroller. I plan to then make a second Beetle board, which will be with a Raspberry Pi chip. But it will take a bit time to finish first this board and then the second one. So, yeah.
Which one? Raspberry Pi 2040? Which chip?
Yeah, the RP2040. That's the second board I'm going to make. Yep.
Mm-hmm. Nice.
Yeah.
I was looking at the progress, so it's nice how you document it. Right? So very nice.
Great. Thank you. So it's open hardware. So this board is on GitHub. I still need to update it because the design is it's almost finished. I can show you guys a little 3D view of what I have right now. Yeah. Let me render it here, and then can I paste screenshots in here?
Should be able to screen share if you can. Can you screen share?
Can I screen share? Yeah, it should be possible.
It's right side to the recording, I think so.
Just so share screen, window, and this one share. So can you guys see my screen is visible?
It's coming up.
Yep.
Oh,
yeah.
Okay.
So that's the design in KiCad. But let's look at the 3D view, and it's not updating. I see. Why is it not visible?
I think you have to switch to another window.
Oh. Wait, I'll try again. Share screen, but I just want to share the entire screen. Yeah, okay, this is better. Yeah, now you can see it, right?
Yeah, it's up.
Yeah, that's what it looks like. Okay, so what you see here is the upper part is the debug probe. The whole upper part up until this line here, which you should think about. This line is going all the way from left to right. So the upper part is the flash debug probe. The lower part is the actual target microcontroller, this one, which has then the breakout pins here and here. This little chip has a very nice capability to run on both either 3V3 or 5V. So with this slide switch, you can select if you want to operate the target chip on 3 volts or 5 volts. Here are some test paths which you can use to monitor the communication between the two chips. I mean, between the flash debug probe on the one hand and the target chip on the other hand. This communication is just flashing the firmware to the target chip, basically, but you can monitor it there if you want. Then this little connector here is like, let me show you guys. Can you see this?
Oh yeah.
Here on my window. So it's a TAC connect.
Flasher.
It's a connector that that you can use to flash
the debugger firmware. Oh.
Yeah, so if I can share my screen again, you can see it, right? So it's a connector that it's like a footprint without an actual connector that you need. You just push this cable, the pins of the cable on there, and then you can flash the firmware to this chip. So it's because this chip here, it's the flash debug probe for the board, but it has to be flashed itself at least once. Yeah, you know, it has to have the right firmware there to operate as the flash debug probe for the target chip. So this connection here is to make that happen. It just needs to happen once to initialize the board, basically, and then it's fully operational. It will operate, as you can see, with an USB-C connector on top. But the USB-C connector, it's only the USB 2.0 data lines are being used, so it's very simple. I'm not using the whole USB-C, how to say, all the USB-C capabilities, just limiting to the USB positive and negative data channels. That's it.
Yeah. So is the debugger firmware open as well? They provide the debugger firmware? Is it open source? Because usually they don't provide, right? Like with the HT or so.
The firmware for this chip here, you mean the debugger? The firmware itself for that one is unfortunately not open source, but they gave me the binary, so it's all I need for the moment.
Okay.
Yeah.
Real quick, Christoph, when you have a chance, can you share your the Discord link or the GitHub link into the chat?
Yeah, sure. Sure, no problem.
I'm gonna, when I have a chance, I'll go in there and I'll branch some of your work into our GitHub repo too.
Yep.
So
I'll share the GitHub link in the DevHead channel on Discord. But cool. I'll first update the design there. I mean, I'll do a Git push and then I'll share it.
Cool. So we actually, it's my job to keep us on time, and I'm like the worst timekeeper ever. But progress on partnerships. So I just want to let people know some things that are coming down the pike. So we've been working on creating demos that help people solve specific challenges. I've done a couple with Umesh. I've done one with Navadeep. I've got one scheduled with Peter. We're recording these. They're like 5 minutes, and they really just go through one specific area, you know, like Umesh, for example, is talking about debugging Cortex-M firmware, like a very specific, I can't even remember what we did at this point, Umesh, but, very specific, challenge that people might face and how to overcome it. So we've got a bunch of those. The first one's launching next week. Pact is really interested in working with us to sort of, essentially promote their books. But on the other hand, we're going to be able to get access to some of their experts on various technology topics to go over them. So I'm working with them to get them to potentially speak on a range of topics in these meetings. Pallav also wants a teardown channel, which basically all of his teardowns would go in, and then we would point people back to the teardown channel if they had questions about a specific teardown or the components or whatever. That would happen in the server. So that's something we're talking to him about this weekend, and hopefully we'll have that up soon. If you have anything that you think would be beneficial or cool, or you'd like to see, or you want to participate in something like demos or whatever, just let me know. I'm at TechieLou on the server. Continuous improvement. Any ideas on getting 1% better? I do have a quick thing before this, which is Electroboffin. If you've been posting your projects, it's often awesome. Keep doing it. Abhishek, you mentioned something. I can't remember. It was back at the top of this meeting about something that Electroboffin had done. If you have those comments, this is exactly the type of stuff to post in response to his post, because among other things, the forum threads are indexed, so it's all about sharing the information that we already have, right, with others. So if you can do that, that's great. But anybody have any thoughts on 1% better by next week? Anything we can do? Anything we can improve? I know I'm going fast, sorry. Everything, we're already at 100%.
I think so.
Great. Okay, cool. All right. Asks and gets. Does anybody need anything or need anything from or have anything for the community at this point? If you don't,
So
if you do,
can I? Okay, Joseph. Can.
sure.
Okay.
Yep.
I just finished my company's website. Like, I wanted to share the link, like, for a review and get feedback from the community, like how the website is, if it needs any changes or any stuff. I hosted it on Netify, so I just need like feedback on the things to change and all that. I'll share the link now. Okay, so give me a second. So this is it.
Yeah,
I just need like a review so I can do iteration.
Yeah, I'll put it in a place you can put it is the project self-promotions tab, and then I think we can create a thread, and then like all of us can just give feedback there. That's probably what I'd suggest doing. But yeah, I'll give it a look over the weekend when I'm on my way back home.
Thanks.
Cool. Good luck, dude. Anything else?
So I was asking about, like, I got 2 modules delivered last week. One is this one, other one is this one. This one is from 2 weeks now. I was thinking to put some tutorials and starting beginner videos, or like any kind of like post or sorts of those things to the channel. And I was wondering about, like, if I can have my own GitHub this thing, or what do we call GitHub kind of a website. If anyone has like a WordPress kind of a template or a theme for like writing blogs or something, they may share it so that like I can start my own and then post the same over here, and the same will be
Yeah.
there.
You can do it over the GitHub pages itself. So you can host it for free with your name.github.io. There are a bunch of Jekyll templates. So Jekyll is a stack over which you can build on, and you can just fork that one and customize it and post blogs over there. That works as well, but it's not SEO optimized, or the visibility is pretty bad in that. So
Okay.
yeah, Brandon, what do you think? When developers websites come up, do contributors
Yeah,
have
so
opportunity to show them?
yeah, so the obvious options are you could do LinkedIn, you could do Medium, right? Medium's I'd probably recommend Medium over
Sure.
LinkedIn at this point. But soon, so we're building a website around this, and I don't want to like completely tie you to this if you don't want to be, but there will be it'll be designed for blogs and articles, right? So there'll be an option there, and you can have your profile page, and we can give you a login to post your own blogs and all that stuff. But if you want something that's completely separate, I think I'd recommend Medium as a place to start.
Sure.
Abhishek, I think I can also provide you my platform as well to do the same.
Yes, I saw the platform. It's pretty crazy, I must say.
Yeah, I think I can do that too.
Sure. We
Can
can
you
connect.
share that? Can you share that with us, with all of us, Electrobot?
Yeah, sure. Just allow me a minute.
Cool.
That would be great.
Cool. Anything else?
Also, like, okay, I wanted to know, like, what kind of starting tutorial should I get? Like 101 to Yocto, 101 to Buildroot, like, if Umesh can help me or anyone, like, for like the starting, like the key names so that I can write around it.
Yeah, me and Umesh will reach out to you separately, and we'll come up with like
Sure.
some
That would be great.
targeted stuff. We also want to do it in a way that's like incrementally building, so you don't
Yeah.
run
That
day.
mind map I was creating yesterday, but I couldn't like in the frame it correctly, so that's why I wanted some. Thank you so
Okay.
much.
Yeah, for sure. All right. Some good resources. Here we added a couple today. Our GitHub repo's up here at the top. There's also a link to down in the resources section of the community. And then our next meeting's all a week from today. So we always do this at 3 o'clock, 1500 GMT on Fridays. If you have anything or you need any questions or you have an idea for a topic, just ping it to me in the server, and we will we'll cover it. All right, fellas.
That's it.
Okay, one thing like which you can cover, and I think Electrobuffin would be the best person for this. So I had struggled a little bit around like 3D printers. So I wanted to get into this domain, but then it is like okay, first get a 3D printer. So if I go to Amazon India, I saw this Ender V3 at 14,000, 16,000, and many other variants were there. And I'm like little confused. Like okay, should I get this one or should I get the other which is selling for 60, 80K? And again, that is a part where I want to get it. Should I even get it, or should I get it from like any robo.in or any website which is there available, which are providing this kind of services? Can you elaborate?
Like at present, robo.in is little bit more expensive. So you can either connect with a friend, like you can let me know whatever requirements you have, I can print it for you. No
Yes.
issues at all. And if you wanted to buy a 3D printer, then I can let you know the 3D printer exactly which I'm using for about 6 months now. So I have currently 3D printers. 2 of them are FDM and one is resin printer. And the best one will be around 13 or 14K. This is the best one which you can get.
Oh, nice.
Let's next time. Do you want to do like a breakdown of the options and sort of like just riff on them, Electrobuffin? I think that'd be cool.
Yeah, sure. Like if there is anything related to 3D printing, you can let me know. Like for the last 3 years, I'm doing everything in 3D printing, like learning a lot.
All right, awesome. All right, fellas.
So, Electro. Yeah, sorry.
Yeah.
You wanted to say something?
No, please.
So Electro. So, how much of the 3D printer is calibration at the end of the day? So, Abhishek and I were discussing in before, like it's not about 3D printer hardware itself. It's more of the calibration and everything. So, that can you add something to that?
So it depends on your like final requirement. What exactly your requirement is? Do you want your parts to be manufactured with the high quality, or you just need a part that only works? So it all depends, and what is the amount of speed you need. So the printer which I am about to recommend is Anycubic Cobra Neo. So it is, I think, one of the best to get at present if you don't need any high temperature materials. If PLA is also the best one and the cheapest one and the easiest one to print out. So you can use that Anycubic Cobra Neo. It will cost you around 13 or 14K on the Amazon itself. It will get you the job done. And if you need high temperature materials like carbon fiber, etc., then I would recommend Bamboo Lab printers, nothing else. They have disrupted the complete market. Like they have overpassed the Prusa Lab, everything. And it will cost you around, I think, 1.5 lakh in India. Bamboo Lab printers, Bamboo Lab X1 Carbon, to be precise.
Thanks for the insight, man. It's costing you around 1.85 lakhs. Yeah, I saw.
Yeah,
Whoa,
Cool.
great.
Yeah, thanks, man, Electro, for your feedback.
yeah, for sure. Like if you need any help regarding the same, do let me know. Ping me on WhatsApp or wherever. I will let you know.
All right, guys. Awesome. Well, I got a jet. I appreciate the all your insight and stuff, and we'll see you in the server.